In this lesson, we're going to talk about parallel lines in the coordinate plane, so meaning on a graph. So the first thing you have to know if we're talking about parallel lines is we're going to have to know how to find the slope. Parallel lines are going to have the same slope, so it's going to be important that we know the slope. So there's a couple different things when we talk about slope. Your formula for slope that you should have already seen, the change in y's over the change in x's, so y2 minus y1 all divided by x2 minus x1. You could also write this as delta y, which means the change in y's over delta x over change in x's, also known as rise over run. So I always count, it's going to be how much I went up or down, and then when I count slope, I'm always going to count to the right. That way, if you moved up, it's going to be a positive number, and if you move down, it's going to be negative. And if we always go to the right, that'll stay positive on the bottom. So if you go up in the end, up and to the right, it's positive, down to the right, it'll be negative. Just another reminder when we talk about slope of a line, if I have a line that looks like this is going to have a positive slope because it's going uphill, or it's going up. A line like this is going to have a negative slope. A flat line or a horizontal line is going to have a zero slope because you're not rising any. And then if you have a vertical line, this is going to be undefined. So that should give you an idea too when you see a picture of a line and you want to find the slope. Right away you should know if it's going to be positive, negative, zero, or undefined before you even do any calculations or plugging into the formula. So let's look at this first example. It says we have these coordinates, so you always want to plot coordinates if they give them to you. So let's go ahead and do that. So we have A is 2, 2. It's going to be important that you guys are labeling these coordinates so that you know which coordinate belongs to which point. 4, 6, so 2, 4, up 6. It's going to be B. And then C is going to be 6, 4, so 2, 4, 6, up 2, 4. And D is 7, 6, so 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6. And the question asks us to graph these. It says graph these lines. So that means I'm going to go ahead and I'm going to connect points A and B. And since they do have arrows above them, that means they are lines, so they're going to go on forever. So you can have your lines just passing through those points. So there's one, and then I can draw the other one. I'm going to go ahead and put arrows on these. So there's my two lines, AB and CD. And we want to determine if, well, first we want to find the slopes of each, and then we're asked to decide if they're parallel. So looking at it, remember parallel lines are lines that are never going to cross. So it looks as if these are never going to cross, but I can't just say that it looks like they're parallel. I actually have to do some calculations. So I'm going to go ahead and I'm going to find the slope. So to find the slope of, let's say, AB, so notice I'm going to put the subscript AB so that I know that that's the slope I'm finding. So M stands for slope. AB is the slope that I'm finding the slope of, or the line that I'm finding the slope of. And then for the first one, let's go ahead and count, and then we'll plug into the formula just to verify. So remember what I said, you're always going to want to count to the right. So if I start at the left-hand side here, the left point is going to be A, and I have to go up 1, 2, 3, 4. So I rise 4. So it was 1, 2, 3, 4, and then over 1, 2. So since it was up 4, it's going to be a positive 4. And since we count to the right, that's just going to stay positive. And you divide that out, you get 2. Now, using the formula, the slope formula, it's the change in y's over the change in x's. So if I look at my coordinates here, let me just write the formula down here so we can see it. So the change in y's over the change in x's. And if I look at my coordinates, that would mean subtract the y values. So I'd have 6 minus 2. And then I would subtract the x values, so 4 minus 2. So that's going to give me 4, that'll give me 2, and in the end I get the same answer. So either way, You could do it using the graph or using the formula. So either way, we get a slope of 2. So then the next one says find the slope of CD. So again, let's just do it both ways to practice it. So if I'm looking at the slope of CD, that means I'm going to start at the leftmost point, which is going to be point C, because that's on the left. And I have to count up 2. So it's rise 2, and then it's over 1, so right 1. So it's going to be a positive 2 over 1, which means it's just 2. Now, using the formula, just to verify that, my change in y's, so it's going to be 6 minus 4 over 7 minus 6. So it'd be 2 over 1, which gives me 2. So same answer. So regardless, using the graph or using the formula, you get a slope of 2. The next one says, are the lines parallel? And explain your answer. So yes, they are parallel because they're never going to cross because they have the same slope. It's the same rate of change. So they'll just stay in the position they are, which will mean they'll never cross and they will be parallel. So the answer is yes, because they have the same slope. So that's on a graph looking at same slope when you're given the coordinates. So the next thing I want to look at is what if you're given the equation? So there's your slope formula and using that. The next thing is what if they give us the equation, how do we determine if the lines are parallel? So if they give you the coordinates, you either plot the points and find the slope or use slope formula to see if they have the same slope. If I'm given the equation, so remember equation of a line, what that looks like. So this is the one formula that you'll probably always remember. Equation of a line is y equals mx plus b. And remember that m stands for the slope. And b is your y-intercept. So if we're given the equation of a line and we want to know if the lines are parallel, well, we need to know this number right here. We need to know m because we need to know if they have the same slopes. So in the box here, parallel lines have equal slopes or same slopes. So that would mean if we look at these examples, we have to get these equations into y equals mx plus b form so that we can compare the slopes this way. So if you look at number 1, these are both in y equals mx plus b form. So all I do is I compare the number in front of x. Those are the slopes. The slopes are not equal, so that means that these lines are not parallel. And that's because the reason for that, slopes are not equal. So it's the same as what we were just doing, where we're looking at are the slopes equal? But in this case, we're given the equation instead of the coordinates. So if we look at the next one here, looking at the slope, which is the number in front of x. Remember, the slope is just the number in front of x. So we have -3, -3, so that means they're parallel. The reason why they're parallel is because they have equal slopes. Number 3 here, the difference is these equations are both not in y equals mx plus b form. So the first thing you have to do is you have to make sure that you get them both in the same format. So I need to take this first equation and get it into y equals form, which really just means I got to divide everything by 2 to get y by itself. So I end up with y equals 2x plus 3. And then the other equation is already in y equals mx plus b form. So if I compare the slopes, now you see that they're equal, which means that they are parallel. So you would just say equal slopes. And if you looked at the original, they are not the same. So it's important that you always get your equation in y equals mx plus b form first so that you're comparing the same thing.